We've seen a massive blow up of transactions recently over the past couple of weeks on a lot of different EVM chains, and that is because of a recent trend that originates from Bitcoin called inscriptions. So are inscriptions just another crypto fad that we're going to see die out over time, or are they actually a genius invention borrowed from the Bitcoin world that we're going to see stay in the long term? Over the past couple of days, I spent a fair bit of time researching all of these inscriptions on various different chains so that I could summarize it in this video for you to make your own decision. Let's dive right into the details. Before we dive into the details of how these work under the hood, I wanted to show you an awesome chart made by Hildobby that will be linked in the description of this video if you want to check it out yourself, to show you the actual scale of the thing we're going to be talking about here, right? And the scale is tremendous. It's reached around 37, it looks like over 35 million inscription related transactions on a single day. And this was actually kind of maintained over a 1.5 month period where we saw, 15 to 30 million inscription related transactions across these EVM chains listed here over, a month and a half on a consistent basis. One final chart before we dive into how this works, I wanted to show you is this gas spent on inscriptions chart, again made by Hildobby, which will be linked below. You can see it actually almost blew up some chains here. This is AVAX C chain in red, and this is Arbitrum 1 in this dark navy blue here. You can see at its peak, it reached over $8 million in gas fees just related to inscription transactions. And you can see this is the scale of what we're going to be talking about here. Over the past month, this has been causing a lot of issues for some chains. I think Arbitrum 1 actually faced some issues where they had some downtime. AVAX C chain, I don't know for sure, but what I've read on Twitter, received a couple of days where the gas fees were kind of unbearable for the users to actually interact with on the main chain. I know they do have their subnet system to kind of avoid this in the long term. This has been dominating almost all EVM related transactions in the past month or two. This has been taking up on some chains on some days over 90% of all transactions on given chains were related to inscriptions. But why is everyone doing this? Why are there so many transactions? What is everyone doing this for? Let's dive into the details. To understand how this is related to Ethereum or EVM related networks, let's first dive into where ordinals or inscriptions originated on the Bitcoin network. Now, when we think of the Bitcoin network, we think of the native currency that you can kind of exchange between addresses on the Bitcoin network as Bitcoin, right? You buy and sell or change Bitcoin between addresses. But the thing about this is you can actually denominate Bitcoin even further into things called Satoshis. Now, the way that this works is pretty simple. It's basically one BTC. Excuse my terrible handwriting here. One BTC is equal to 100 million Satoshis, SAT. And this is actually pretty obvious when you think about it. You don't always want to send one BTC, right? Just like you don't want to pay in denominations of $1, you want to pay in denominations of cents, right? So one Bitcoin, when you're actually sending 0.0001 Bitcoin to someone, that is being broken up into these Satoshis here. Now, when we think about Bitcoin, we think of digital gold, and pretty much you buy and forget about it, right? It's a digital store of value that doesn't have much utility other than being that kind of digital gold. Then a couple of years later, from Bitcoin, Ethereum was made to enable these smart contracts or applications to be built in a decentralized manner, which is something that Bitcoin can't do. So during around 2021 and the NFT boom and things like this, Bitcoin was mostly left out because it just doesn't have the capability built in and likely never will to enable these decentralized applications to be stored and executed in that Bitcoin network. The thing about NFTs as kind of a broad generalization is a high percentage of projects actually don't really do anything in terms of on-chain mechanics, right? A lot of NFT projects essentially use a standardized smart contract such as 1155 or 721 and actually store the information about the NFTs or the digital collectibles that most of them are off the actual blockchain itself and use services like IPFS or sometimes even centralized services like S3 to actually store that information on a server. So inscriptions or ordinals, as they're often called, and we'll kind of explain the difference between those two in a moment here, saw this on the Bitcoin network and kind of said, well, there's no real code or execution required to even do this. You can actually just inscribe information onto each individual Satoshi. So imagine you select this Satoshi and it has a given ordinal number, which we'll explain how that works in a second. And you just associate some arbitrary content, such as the metadata of an NFT, like an image, a description, a name, some properties like traits, for example, onto that specific Satoshi. And that is essentially like a pseudo NFT, right? You give this specific Satoshi, which has a given number, and we'll talk about how those numbers work in a second here. Imagine you just inscribe, quote unquote, inscribe some arbitrary content onto that specific Satoshi, which has a unique number. Okay, so we know the term inscriptions comes from inscribing, which really just means associating, or kind of in your mind, in your mental model, you can kind of just imagine like etching metadata into a given Satoshi. That's at least the way that I think of it. What does ordinal mean, and how do these different Satoshis get identified using these ordinal numbers? That's what we're going to quickly jump over now. I will link the full documentation if you want to dive into it yourself in the description. It is kind of detailed and a little complex, to be honest, but I'm going to try and simplify it. And then we're going to go in a little bit deeper in what the concepts are that got borrowed from the Bitcoin world over to the EVM world are, and we'll dive deeper into how it actually is implemented in the EVM world, which is what we're going to focus on in this video. So just so you have the context of where the ordinal term comes from in the Bitcoin world, it's actually relatively simple, right? So each Satoshi is associated with a given number. That number is the number in kind of chronological order that specific Satoshi was mined, right? So the first Satoshi that was mined, you can imagine, has an ordinal number of 0. And if you wanted to make an NFT, for example, I'm using these terms kind of broadly, but if you wanted to associate any arbitrary content, such as the metadata of an NFT, into Satoshi number 0, you would then have to have Satoshi number 0 and do that inscription process, which we'll briefly touch on in the next kind of section, into Satoshi 0, which was the first ever mined Satoshi, right? And then Satoshi number 1 would be the next one. Satoshi number 2 would be the next one. 3, 4, 5, up until however many Satoshis have been mined at this present moment, right? Which I think is a couple quadrillion. So there's a lot of them. So essentially each of these Satoshis get mined, and you can therefore inscribe information into each individual Satoshi. And essentially that number, the ordinal number of the Satoshi, can be represented in a couple different ways, like the integer notation, decimal, degree, percentile. You can pretty much just like imagine transforming the number that it was mined into different ways. I don't know why this is even here. It's just you can represent the number in different ways, right? So then it says arbitrary assets such as NFTs, security tokens, accounts, or stablecoins can be attached to Satoshis using ordinal numbers as stable identifiers. So essentially this is saying each Satoshi has a unique number that it's never going to change, right? It's the number that it was mined. That information is never going to change over time. And you can then say, well, this is my Satoshi. I'm going to inscribe some information into it, and that will remain as kind of a fact on the blockchain forever. The final piece that I wanted to cover before moving into the EVM world is a brief dumbed down explanation, because I don't fully deeply understand how this actually inscribing process works. But the little understanding that I do have here is that it uses this Taproot script upgrade, which is essentially an upgrade made to Bitcoin in the Taproot upgrade that, from my understanding, allows you to essentially associate information such as this, for example, where you would inscribe an ordinal that says hello world to a given transaction. So you're actually making a transaction and including, I should say, this information as part of the Taproot script, for example, in that transaction. And this is actually a two-part process. If you want to read the full details, I will again leave the link here. But the summary is you make a transaction with a given Satoshi. Let's say I wanted to inscribe Satoshi number 1. I would include this information in a transaction where I'm transferring Satoshi number 1, include this. And this is actually a two-part process again. It's a little more complex than I'm making it out here. But I would essentially inscribe it by including this information in that transaction, which essentially says, well, I've made a transaction with Satoshi number 1. I've included this information. That information is never going to change. It's always going to be stored in a decentralized manner. And therefore, I have essentially minted a kind of pseudo NFT that says hello world. And that information is always going to be on chain. It's never going to be taken away from me and can be read permissionlessly by anyone, which shares a lot of the properties that an NFT does in the EVM or Ethereum world. So that's a very brief overview of where this really came from. It originated on the Bitcoin network, and a brief overview of how the Satoshis using ordinal theory are kind of uniquely identified and inscribed with any arbitrary information. And the reason this was kind of introduced into the Bitcoin network, and I use that word lightly, is because there was no change made to Bitcoin to include this kind of new addition or new feature, right? This is built, out of the box, has support from the Bitcoin network to actually enable this kind of behavior, because all you're doing is sending transactions between each other, where you're just transferring Bitcoin between two different addresses and just writing almost notes in those transactions to say, okay, I'm actually inscribing this arbitrary content into my Satoshi that I'm transferring by including it in that kind of Taproot script section of that transaction. So then the question is, why did we see this on chains like Polygon POS or on Base, on OP Mainnet, on all these EVM chains where we saw, consistently for weeks, over 15 million transactions almost every day on Polygon POS alone, for example, in this chart you can see. Why are people doing this on EVM chains? On the EVM, we have smart contracts, we have NFT contracts, we have NFT standards, we have token standards like ERC20. Why are people doing the same inscription process? Is it the same thing on the EVM world? And what are the kind of pros and cons to this approach compared to traditional smart contracts? The process comparing Bitcoin inscriptions and EVM inscriptions, or sometimes called ETH-scriptions, is actually very similar in the principle and the concept, right? So what we just talked about was address A on Bitcoin. Let's say they want to inscribe their Satoshi. They could either, I believe, transfer to themselves. Again, I'm no Bitcoin expert, or they could transfer it to a different address. And they would transfer a specific Satoshi that is identified using that ordinal theory, which has a unique number for that Satoshi based on when it was mined. Inside that transaction, you would include this kind of note called the Taproot script, which was made available in Bitcoin's Taproot upgrade, from my understanding, where you can put any kind of arbitrary data, right? So this is an example taken from the ordinals documentation to say, here is a ordinal of type text, plain text that says hello world. And that is the process of inscribing a Satoshi in the Bitcoin world. And this is actually almost copy and pasted to Ethereum. The difference is in Ethereum, we have address A sending the transfer event to address B, or they can even send it to themselves, for example. And instead of Satoshi, they're sending ETH, which is denominated into ETH. ETH has 18 decimals, so you can send 0.0000000 18 decimals 1 ETH that is denominated in itself, rather than Bitcoin being denominated into Satoshis, for example. And this actually has a very similar concept. Instead of a Taproot script, it is called call data. So you can include any kind of arbitrary information such as, hey, my name is Jared in the call data. You can send notes to, let's say, tag kind of why you're sending address B this money. Let's say you're paying them for something this is commonly used for is negotiating hacks is probably the most common use case I've seen for call data, where you see hackers communicating with the protocol engineers in the call data messages, which is sad and funny at the same time, but it's kind of a tangent. The concept is almost identical, right? You're sending transactions, and within that transaction, you're including a note alongside it to actually inscribe or mint a token or mint an NFT or transfer an NFT or transfer a token. Again, using these words lightly, as they are all just pieces of information stored in this call data field here. So the concept is very similar. In Bitcoin, we saw that in the Taproot script. In Ethereum, we're seeing it in this field called call data, as we'll explore later in this video. Here I have an example that will kind of hopefully solidify what we've been talking about in your mental model of these inscriptions in the EVM world. As you can see at the very top, we have, for example, this is just a random example of an inscription related transaction I found. Not promoting this or trying to call out this address. This is just an example transaction. You can see this is coming from and sending to the exact same wallet address. So this is going to be a transaction that is initiated from person A sending the transaction to themselves. They send 0 value, so it's a transaction transferring 0 Matic. In this case, this is from the Polygon POS network. There is a very minuscule fee, which is something that we're going to talk about a little bit more here. You can see this is 0 cents, which, even for Matic, which is, often very cheap in transaction fees. This is a very, very small fee to perform this transaction. And the most important part here is this call data section down here, which my head is kind of blocking, but you can see I've tagged this as call data here. In this, and this is really just a notes field, you can put pretty much any information you want here, but this is structured in such a way that it says, okay, here's the PRC20 standard, which I think is like ERC20, but since it's on Polygon, it's PRC20. And this person is minting Pol's token. And the amount is like 10 million or something like that. I can't see off the top of my head, but essentially they're just noting down that they're minting this number of tokens of this ticker or token, Pol's. And the standard that they're using is PRC20, which I don't know the full details of. Here is another example of the call data that I've kind of decrypted here. Another example transaction. You can see this one is actually inscribing an image directly in the call data. So it's base64 encoded an image, which you can easily do using some basic JavaScript or any programming language really to encode it into this base64 encryption, which essentially you can imagine just takes the image, transforms it into numbers and letters that represent that image, and pasted that in the call data to represent what I imagine is an NFT or the image of an NFT. You can see here it says this is of kind image JPEG. So it seems like a JPEG image is being placed into this call data here. So this is pretty interesting because at first I kind of hated this and thought it was pretty stupid. But the more I thought about it and the properties that you get out of this are actually somewhat interesting and worth considering, right? Because when you think of the value of the blockchain, you think, okay, I want to store information in a way that is permissionlessly accessible by everyone. It can't be taken away from me. It's going to be there permanently. And the information isn't going to change over time unless I wanted to as the creator of that information, right? And these inscriptions, by writing notes and inscribing information into transactions this way, it kind of satisfies all of that criteria in a weird way. And the weird way it does that is just putting notes of what you kind of pretend to do in a transaction where you actually do nothing, right? So the EVM isn't really doing anything here. It's not like performing some mint of a token and transferring it to your address. Nothing's actually really happening. You're literally sending yourself $0 or 0 Matic in the example that we looked at for a very small fee, and you just write a little note that says, in this transaction, I minted 10 million of this particular token. And you might, at first, when you kind of say it out loud, it's like, well, that's stupid. You're just pretending to do it. But it's actually permanently storing information on the blockchain that is accessible by everyone and can never be taken away from you. So you're writing down information onto the blockchain, right, in this kind of ledger technology that we all know and love and have probably heard hundreds of times by now. All of the values that you want of the blockchain are kind of satisfied by this methodology of inscribing transactions with call data, or in the case of Bitcoin, by inscribing those Satoshis, those transfers of Satoshis with the Taproot script. The reason, at least from my understanding, that people are doing this is because the fees are substantially lower than actually transferring or minting the tokens as you would typically with ERC 721 or 1155 NFT smart contracts or ERC20 tokens. The fees to send yourself nothing and write a little note are substantially lower than calling a kind of complex smart contract which has executing different lines of code, it's transferring tokens, it's taking money away from you in a lot of cases, it's checking things like allow lists, for example, and a lot of difficult and complex code is often being executed, which leads to higher gas fees to actually interact with these NFT contracts or these ERC20 token contracts. And we're not talking like massive fees, right? If you've ever interacted with Polygon POS, for example, you're talking like sub-cent or a couple of cents maybe to interact with these NFT contracts or ERC20 token contracts. This is not a huge price issue on these EVM chains like Polygon POS. If you're dealing with Ethereum, it's probably a different story. But the gas fees are still substantially lower to do these kind of mock transactions or these pretend transactions where you just write in the call data, here's what I would have done almost, or here's what I'm doing, I guess you can say. I'm minting this stuff, but it's not really executing any code in the EVM. The way that this kind of works in marketplaces and things like that is it scrapes this, at least from my understanding, this is how it works. It scrapes all transactions with call data of this kind of data structure, where it starts with things like data, has these specific fields. I don't know the full details of what it looks for in the scraping, but all of these transactions related to inscriptions follow a similar structure to this call data, right? And you can basically say, well, here's all of the transactions that occurred. Here's the ones with call data that follows the inscription standards. And then you pull all of that information off chain, which anyone can do, and serve that up into an application where your users can kind of interact with it as they would typically with an NFT application like OpenSea, for example, or a token application, which I don't have any examples off the top of my head. But essentially, all this information is pulled off chain, organized in a manner where, okay, this happened, this happened, this happened, this happened, and the current state of the inscriptions is served to you in these applications from that off-chain data that is scraped from these transactions. So what these marketplaces would do is essentially read all of those transactions and build the history to reach what is the current point the current state at the current point in time, right? So you could say, as an indexer myself, I could say, well, I'm going to scrape all of these transactions related to inscriptions. I see Jared minted 100 Jared tokens. He transferred 50 of them to Bob. Bob transferred 25 of them to Caroline, et cetera, right? And then you kind of rebuild the current state and serve that to the users and verify which of those inscriptions are valid or not. And that itself is kind of the downside to this method, right? Is because there's no on-chain method to, at least from my understanding, there's no on-chain method to stop any kind of invalid transactions going through, such as, for example, if I wanted to transfer 100 tokens that I don't own, I can send a transaction like this. There's nothing stopping me from doing that, right? I could send it. And it's up to the off-chain indexes to say, well, you didn't actually receive or you didn't mint those tokens. You can't transfer something you don't have. There's nothing stopping me from doing this, right? I could give myself 1 billion of old tokens, and that would go through as an accepted transaction. But it's up to the indexes off-chain to say, well, you never actually got those tokens, so that's an invalid inscription-related transaction. And this leads to a couple of different downsides, from my opinion, is that on chain, you can never read the current state of an inscription token, right? You can't read how many tokens a given address has. You can't say build an NFT gated website based on purely reading the current state of the chain. You can't have a smart contract check the balance of a wallet's inscription tokens. You can't see in one smart contract function to say, well, does this wallet have 10 Jared tokens or 10 polls, for example, in that example that we just looked at. There's no on-chain logic here. It's all writing notes on-chain, right? Submitting transactions that contain notes of what you want to execute, but there's no verification at that point. It's entirely up to the off-chain scrapers almost, or the off-chain indexes, as I should say, to rebuild the history and serve that into applications. Now, if you compare that to something like OpenSea, you can imagine the reason they are able to load these pages so quickly, for example, is because they're actually doing the same thing. And I don't know this for sure, but building an NFT marketplace, you're not going to load all this information off chain. And I would be super impressed if they did with these load speeds. This is likely being indexed behind the scenes by a company like OpenSea's engineering team to say, well, we're going to load all of this information off chain, store it off chain, I should say, load it from on chain and store it off chain to load things like what the price history of this NFT is, what the previous listings of the NFT is, things like this, right? The things that are not directly on chain, you're going to load off chain and serve that from probably a database here. Now, the argument to that I have is if I try and buy this and it's already been sold, for example, that's not going to go through. And I don't think I can say the same for inscriptions. And the reason for that is inscriptions are purely relying on what is the latest off-chain information that they have indexed is and serving that to an application. Whereas if I do the same thing on OpenSea, yes, what I'm seeing on this current page has probably been loaded from a database. But if I try and buy this and the price has changed, or I don't have enough money, or it's already been sold to someone, or it's been taken off the market, it's first reading the state of the smart contract that is going to execute under the hood. It's reading on-chain data, it's executing on-chain logic, and that is always going to overrule anything that I'm being served here that is not on-chain. So the pros and cons are essentially it's cheaper to write yourself a note and send yourself a transaction with call data than it is to interact with smart contracts. And that is because smart contracts are doing complex things, right? If you want the benefit of a smart contract to run the rules according to what the EVM has defined and run that bytecode as the machine expects and will always execute 100% the exact same thing every single time. If you want that, it's going to cost you more in gas fees. So it's essentially saying, well, do I want to pay less gas fees for almost a less secure experience, or do I want to pay more gas fees to use smart contracts which execute complex logic, but then because of that complex logic being executed by the EVM, someone needs to be rewarded for executing that compute power that is going to cost more in gas fees. So that is the ultimate deep dive to inscriptions in both the Bitcoin world and the EVM world. Again, all of the resources that we talked about today will be linked in the description. If you enjoyed this video, I would really appreciate it if you hit the like button and the subscribe button if you want to see more Web3 content like this coming soon. Appreciate you watching, and I'll see you in the next one.